Okay, in the second part of the superposition, we've got another example, and it's pretty simple. We got 2K, 2K, 4K, 4K. Now the two power supplies, or the battery sources, DC sources, we've got a 12 volt, and the 12 volt hooks into the positive terminal, hooks into the ground bus. Then we've got a 6 volt battery, and the negative hooks into the ground bus, which is kind of what you normally expect, but can go either way. So what we have is we short out the 6 volts over here, and that's just shorted with this wire. And then what we have is we have this 2K and 2K becomes 4K. And that'll be, this 4K will be in parallel with this 4K, which creates 2K. So we have our 12 volt battery, 4K and 2K. So we've got 12 volts over 6K, which is 2 milliamps. Now when we look at this, how it divides, because they're equal, we have 2 milliamps going in, and then it divides out 1 milliamp this way and 1 milliamp this way, because they're both 4Ks. And that's the way that one works. Now when we short out the 12 volts, we put the short there, now what we have is we have this 4K and this 4K in parallel again, so that makes 2K. So we've got the 6 volts, 4K, and 2K. So we've got total current is 1 milliamp, 6 volts divided by 6K. And if we zoom in, how that's divided up is we've got 1 milliamp going out, and then because they're both 4Ks, they divide evenly, half a milliamp here and half a milliamp here. So if we go, and what we'll try to do is open up both of these pages and try to view them both. Okay, so if we add these both up, what we've got is we've got this 2K plus this 0.5K makes 2.5K. If we can blow this one up a little bit, 2.5K. Over here we've got 1 milliamp this way and a half a milliamp going the other way, so it turns out to be only a half milliamp there. And then here we have we have 1 milliamp here, and then 1 milliamp here, which makes 2 milliamps. So if we add up the sum, and remember this is all 0 volts here. So even though this plus is shown here, it's really at 0 volts. So since there's 12 volts difference, that means that this is 0 and this is minus 12 right at point X. And so point VB is going to be minus 12 volts plus 2.5 milliamps over the 4K resistor will be 10 volts, which makes that minus 12 plus 10 is minus 2 volts. And then for point A, if we take the 2K over 1/2 a mil, that's 1 volt, so this becomes minus 1 volt. And then if we go down here, we have minus 1 volt at VA, and then if we take that half mil through the 2K, again, that'll be 1 volt, so we get back to 0 volts. And if we wanted to go the other way, we're at minus 12 here, we're at minus 2 here, and then we have 2 milliamps over 4K, which is 8 volts, so we go minus 2 plus 8 is plus 6. And that all checks out. And let's see how the Multisim looks. And if we do this, and we have it, if we have it set up, and what we've got here is we've just got voltmeters between our ground point and here, and the ground is again all over here. If we run the simulation, what we get is minus 1 volt, and that's at this point VA, and minus 2 volts at VB. Now if we want to take a look at what some of the currents are and compare them to what we had in our drawings, we can we have to stop it to change it, but we pull in a voltmeter, and what we'll do here is we'll bring this down here and we'll flip it and we'll bring it in here, and we have to get rid of that guy. And again, this will be measuring the 6 volt current. Now what we'll do for our superposition is we'll make that 0 for the time being. So we'll see what this source does by itself. And we also have to change this to amps. So now this one will be on amps, and we'll take a look and we'll run the simulation. And here we get 1 milliamp coming out of the 6 volt source. And if we look again, what we had going out of that one, for the 6 volt source, when we have no 12 volts, we have 1 milliamp. And that 1 milliamp comes out of the battery terminal. Now, if we want to do the same thing and see what the 12 volt source is doing, we can change this back to 12 volts. And we can only do that when the simulation is off. And we'll change this one to 0. And now what we'll do is we'll take our ammeter and we'll hook it in here, and we'll plug in a new ammeter, bring it across, and we'll have to flip it a little bit. And again, what we want to do is we always, because the electrons come out of the negative terminal, we want to bring them into the negative terminal of the power supply, or the meter. And we'll get rid of that guy. And now we should be able to go and see what the 12 volt supply is going to supply. So we turn this on, and again now this meter is going to set it up for current, and now we'll go and run the program. So here, this is 2 milliamps. And let's see what that agrees with what we have in our drawing. And when we have this one, this is 2 milliamps, so that agrees. And that is the superposition part number 2.